Hello everyone, in this video we're going to derive the quadratic formula or the quadratic equation. So first let's start by why would we want a quadratic formula? Like what's its use, right? So normally in algebra you have equations such as, for example, 5x plus 2 is equal to 7, right? And this type of equation is easy to solve because you just use normal techniques of algebra and you can get x equals 1. And similarly there are equations like, okay, you have x plus 2 squared, for example, is equal to 9. Here it's also fairly straightforward because you can take the square root of both sides and conclude that x can either be x can be 1, for example, because 1 plus 2 squared is 3. Or x can be also -5, because -5 plus 2 is -3, and that squared is 9. So this is fairly simple. But then say you have an equation such as, like, 3x squared minus 4x is equal to 4. So in this case, it, x is 2 here, but it's not that straightforward to solve. It's not that straightforward to solve using the traditional technique. So that's where the quadratic formula comes in, where we can solve any general equation that has the coefficients on x squared, on x, and some constant, and we can solve for the value of x, right? So how do we go about finding a way to solve this? So first of all, let's write a general equation that will represent the equations or the formulas we're trying to solve. So let's say we have some coefficient a on the x squared plus some coefficient b on the x plus some constant c is equal to 0, and are given these three constants a, b, c and a variable x, we have to solve for x in terms of a, b, and c. So in this case, like, let's say a would be 3, b would be -4, and c would also be -4, right? Because we just kept it as equals to 0 for for ease of use. So how do we go about solving this? So before I get into this, in algebra there's a technique called completing the square, where if you have two variables, let's say s plus r squared, right? We know that this, if you expand this, is basically s squared plus 2sr plus r squared, right? So our goal is to try and get this equation into something like this, so we can take the square root and isolate x alone, right? So if we get it to something like that, then it's easier to solve for x because we can just take the square root and then solve for x, right? So the goal is, how do we go from this to something like this, where we can express it as a square of something. So let's say I start just by isolating x squared, right? I divide this whole thing by a, right? If I do that, I get x squared plus b over a x plus c over a is equal to 0, right? Because we divide the whole thing by x. So now let's say in this equation we take these two terms to be s squared and 2sr, right? So in this case our s is simply just x, because that's x squared, and 2sr is equal to b over ax, right? So this is this one. Now we want to be able to find r squared so that we can add that here and take the square root, right? So first of all, let's find r, right? So we know that s, we let s to equal to x, so this will be 2 times x times r is equal to b over a x. So then to get r, it will be r is equal to b over 2a, right? Because x gets cancelled and you divide the 2 here. So that would be r. And so therefore r squared is b squared over 4a, right? Because the square of b is b squared, the square of 2a is 4a squared, right? So now that we have our r squared, we took this to be, we took this over here to be s squared, we took this to be 2sr, and now let's add our r squared, right? So going here, we'll have x squared plus b over ax, right? Now I'm going to add r squared, right? So r squared is going to be b squared over 4a squared, right? But now you must be thinking, hey, you can't just add something to the equation, because this is an equation. How can you just randomly add something? Well, yeah, you're right. Now that I've added it, I have to also subtract it, right? Because I can't make the equation imbalanced. So I'm adding this, but I'm also subtracting it. So effectively it's 0, but it'll help us simplify this this side. And then plus c over a, because that's still remaining from over here if you look at this. And then we set this equal to 0, right? Because that's the, that's the one, the equation we have over here. So now this, we expressed it as s squared plus 2sr plus r squared, right? If you remember from here. So this can be simplified as s plus r squared, and our s obviously is x, and our r is b over 2a from here. So we have x plus b over 2a quantity squared. This is s plus r squared. And this technique is called completing the square, where we find the missing term in this formula and then add and subtract it, right? So that's called completing the square in algebra. And so now that we have x plus b over 2a squared, that's this term, minus this one over here, that's b squared over 4a squared, plus c over a is equal to 0. Now we just move these two terms to the other side. So we'll have x plus b over 2a squared is equal to b squared over 4a squared minus c over a, right? Now I'm just going to take the square root on both sides, right? So taking the square root on both sides, here we'll have x plus b over 2a, right? So, taking the square root helps us simplify this and remove the square and make it an easier to manage equation, something like that we have over here, right? So x plus b over 2a is equal to, now this, since we're taking the square root, the root can be either positive or negative, right? So this will be plus minus the square root, and then this, let's combine these terms. So the least common denominator of these two is 4a squared, right? And then this is just b squared, and then this one, 4a squared divided by a is 4a times c, that's 4ac, and so that's what we have. And 4a squared is a perfect square, so then we can simplify this to x equals, let's move this to the other side, so negative b over 2a plus minus, the numerator here will remain square root of b squared minus 4ac, and the denominator becomes square root of 4a squared, that's 2a. So from this we can solve the quadratic equation, that's basically x equals negative b plus minus square root of b squared minus 4ac all over 2a. And this is how we derive the famous quadratic equation. And so if you notice, if we use these values, right, and we substitute them here, let's see. So negative b, that's negative b is simply 4, right? Plus minus square root of b squared is actually 16 minus 4ac, so that's 16 times 3, which will be 4 actually, so minus 4 times a, which is 3, times c, which is negative 4, right? All over 2a, so that's 6, right? 2 times 3 is 6. So 4 plus minus, this is 16 plus, this will be 48. So 16 plus 48 is 64, square root of 64 is 8, right? So that's 4 plus minus 8 over 6. So we'll have 12 over 6 as one answer and negative 4 over 6 as another answer. And 12 over 6 is indeed 2, right? Which is what we had initially, but there's also another answer that satisfies the equation. So yeah, that shows that the formula we derived actually works. And I hope you enjoyed this video, and I'll see you in the next one. Cheers.